Okay. Greetings in the love and light of the Infinite Creator. I'm Andre Zvorgan, joined here today with Jean Laherrère, Roger Bentley, Dan, and Gail Tverberg. And we're going to begin with a presentation from Jean and Roger about the forecast updates for the world oil. And then Arthur Berman should join us for the second hour on the adaptive oil markets. And Gail may also tell us about how affordability ties into the reality. Okay. Roger, would you like to introduce yourself?
I'll start off myself. I've been very privileged to work with Jean Laherrère and with Colin Campbell from the early days of the reports they did with Petroconsultants on oil and gas. Very privileged, worked about 30 years, Jean longer than me. And my background was physics and chemistry, and then solar energy, and then oil. And I'm still writing papers, helping Jean write his. Okay, Jean, perhaps you introduce yourself, Jean, briefly.
Well, first, I'm an old man. I'm today 95 years old. So you can see I've been working on oil for a long time. I started with the discovery of the largest oil field and gas field in Africa, Assimi Saoud and Assimi in 1956. And also, I moved from two different places, and I went to Australia. I went 5 years. I was living there to Colin Campbell and now to Roger. But I like to make graph, and for me, you understand.
Okay.
Things only when you see on graph.
Okay, thank you. All right, so Roger, here's the first slide.
Thank you, Andre. So yes, so this is a report, a big report that Jean has done on world fossil fuel, all the fossil fuels forecast to 2150. We'll go through it, it's fairly short. As Jean says, he was head of exploration techniques. The big report exists, it's on the ASPO France website, and I and 3 others are helping him to write a paper, submitting a paper on the same thing, a cut down paper.
Roger, may I stop? I'm sorry to stop you. You see, most of the report in the past were was data in volume. For the first time, it was data in weight. It is completely different.
Yes.
This is why I think this report is different from what I did in the past.
Very, very good. Thank you, Jean. That is a very good point. So he says most of his studies in the past are by volume, barrels of oil, and so on, cubic feet of gas. And now he's doing weight, which makes it more comparable. So very good. Can we just go back to the previous one, Andrew, briefly? Yes, because there he is. Jean was an associate consultant at Petroconsultants on those first 3 reports, 1994 to 1996, were groundbreaking. Petroconsultants was there before IHS Energy, turned into IHS Energy, and now S&P Global. An important point, Petroconsultants had decided they would share the oil consultancy data and ask in people like Jean to be associate consultants to write these really landmark reports. So they were absolutely solidly based on really good data. And you can see 3 major reports there: petroleum potential, supply of oil, and gas potential. Really, really good. And out of that came the really famous landmark paper, Colin Campbell and Jean Laherrère, End of Cheap Oil, the End of Cheap Oil, Scientific American, which has, of course, turned out to be completely correct, as we will show. And then there's some other papers, many on the ASPO website, which Jean has written over the years. But as he says, this one on fossil fuels is the first to be weight-based, not volume-based. And then you've got some other papers there that are in press and in train. Okay, thank you. Next slide, please. So this is the main conclusion from the main report. Extraordinary figures that you'll be presenting. You've got historical production from a data set that ASPO France has been collecting. ASPO France has been collecting data. Historical production from 90, it's a wonderful thing, 1900 to 2150. You don't normally see charts quite so long, but Jean is a chart expert. And you can see it's in gigatons, so it's by weight. Coal in black goes up, and peaks in Jean's analysis, which we'll discuss later, about now, 2025. Oil, the green, of course, went up in the 70s and then went down with the oil shocks of the 70s. Gail Tverberg and others are all well aware of all this, and then has gone up. And is shown here, oil going over the top and down. Likewise, gas, conventional gas, to be fair. And then also in this model is brown coal, the kind of Movi one, shale gas, the green. It's been significant, but it's not a huge amount. And then coal bed methane. So that's that. We'll look at that graph again later on. But that's the main message, that they're all more or less at peak. And we'll discuss which ones are resource limited peak. And that's important, real reflecting resource limits, and which ones are reflecting more cost and so on. So we go to the next slide, please. Thank you, Andre. Here's a wonderful chart from Jean. Hubbert Linearization. Hubbert Linearization developed by MK Marion King Hubbert. If a resource, if a mineral or resource is following in its cumulative production, if its cumulative production is following a logistic curve, one that goes up exponentially and then goes through an inflection point and goes down exponentially, if it's following that, then as Hubbert showed, if you plot it on this graph, which is annual production divided by cumulative production on the y-axis and cumulative production on the x-axis, if it's following perfectly that chart, it never does, because of course it starts at 0 and the logistic curve starts at minus infinity, so it can never follow it to begin with. But pretty soon, if it is following a logistic curve, the production, cumulative production of that mineral or resource, then you start to get a straight line. And here, amazingly, oil, global oil production, a straight line for many years, all pointing to a limit that production will cease when there will be no more production. You've used all your ultimate resources when you've reached 400 gigatons of oil. And importantly, never to be forgotten, Andre and everybody else, you actually go over the midpoint halfway through. So you might have lots and lots of oil or coal or chromium left, but you go over the midpoint and it starts declining. So that's the background number that Jean generated with one of his wonderful graphs. And then the next slide, please, shows what that says about the world output. So Jean takes that 400 gigatons, as you can see, 390 gigatons, and shows that the cumulative goes up. As you can see on the cumulative curve, the kind of purple one, you've already gone up and you're past the inflection point and you're going to go over the top. And so again, global oil, you had the 1970s production peaks right down because the price shot up, as we'll look at later. And then the price went back for a while and over the peak. So this is all oil, global all oil. But then if you look just at conventional oil, that subset, then in fact, since 2005, the marginal barrels have been the non-conventional oils and the NGLs. And this had 4 effects: put up the price of oil, increased decline rates, more CO2 emissions per average barrel, and a lower energy return, Charlie Hall's favorite important parameter, energy return on energy invested, which Andrew's workshops have discussed on many a time and will discuss in future. So that's global oil. And here we go. Let's look now at the conventional oil. Here's a lovely chart from the IEA, International Energy Agency, produced only 2025, late 2025. Total production 2000 to 2024 of global oil, IEA definitions. And you've got onshore conventional, dark blue, shallow conventional, light blue, deep water, the darker blue still. You put all those together and you can see that global production of conventional oil, those three together, onshore conventional, shallow offshore, shallow deep water offshore conventional, actually reached plateau in 2005, went at plateau to about 2008 and has been declined since. And we did a lovely little survey of some people in London Energy Institute. Not one of them, all experts, not one of them knew that global conventional oil had reached maximum and was in decline. Not one of them.
Wow.
And so what have we produced since? We've still been producing more oil. As you can see, most of it has been natural gas liquids. Some, this only goes to 2024, is light tight oil in mostly America, some in Canada, some in other places. And then there is some extra heavy oil, tar sands, Orinoco, and then some other categories. But global conventional oil plateau from 2005 to 2008, in decline since, and then that's the other oils we've produced. And this is a lovely IEA plot. Okay, is that all clear, Andrea? Are you clear enough?
Yeah.
Next slide, please. So one more on the conventional oil, very similar one, produced some time ago. A combination of global shift data. If you want to know anything about oil, go to the globalshift.co.uk website. Again, you've got the nice thing about this to this chart, we added the price of oil. So you can see for many, many years, the real terms price of oil was only $25 a barrel for a long time, 1925. This is 100 years this covers. And then suddenly the shocks of the 70s, I lived through them. The first increase in 73 and then the second increase in 78. Thank you, Andrew, for pointing it out. Then she fell back, but importantly did not fall back to the previous price because we are now producing more difficult oil. North Sea oil in the UK, for instance, and Alaska oil. We're producing more difficult, more expensive oil. And then we hit the 2005 global conventional oil, and boy, oh boy, she shot back up again. And we're back up at $80, $90 a barrel. She shot up to 140, and then she came down, but we're still twice as much. So the crucial thing on the prices, 50 years of only about $25 a barrel. First oil shocks up to the roof, destroyed economies, down but more expensive for about 20 years. And then after the 2005, we hit the end of the plateau of global conventional oil. Up goes the price again, and now we're up at $70 or $80 a barrel. It's a new world, and that's a simple message that 95% of all energy analysts haven't got into their head. And there again, you see quite clearly the NGLs going up and a little bit of biofuels at the top, but conventional oil flat as a pancake. Okay, thank you, Andrew. Is that all clear, everybody? Any questions so far? Okay, I push on. So that was oil. Now we do the same thing for conventional natural gas, another splendid Jean Laherrère chart, another Hubbert linearization, saying that if it was following a logistic curve, cumulative production of global natural gas, if it was following a logistic curve, it would give you a straight line, and here it does, indicating something like 190 tons, isn't it, of gigatons equivalent, billion tons, that's right, billion tons, going in that direction. And if you take that ultimate, that's the total amount that will be produced, indicates the total amount will be produced in the world of that commodity. Then we go to the next slide, please. Andrew, you're very good. And this is what it says for natural gas production. Once again, peak about now. So it's very interesting. Peak of just about everything is about now. That takes a ultimate UR ultimate recoverable resource of 175 gigabarrels. There's the cumulative production curve going up and turning over, and there's the annual production curve up and down. And crucially, Jean, in these models, sees the decline. They are Hubbert curves. The sees the decline is constrained by the ultimate recoverable. That's the constraint. And then he sees the decline as roughly symmetric to the increase, not exactly symmetric, and who knows how it goes exactly. But as we all know, the crucial point is not really the decline. It's going over the top and back down. That's where society changes. Good chart from Jean, March 2026. Let's look briefly at another one, natural gas plant liquids. It's always tricky, as Jean knows, to separate out natural gas from the fields, and those that have been produced in plants specifically. The US has changed its rules a number of years ago and so on, but again, an indication that there's perhaps going to be nearly 40 gigatons of natural gas plant liquids produced. And ultimately, and if that's true, then we've still got some way to go up. We haven't reached the peak. The peak isn't until 2020, 2030 or something. I can't actually see it, actually. 2030 or something.
2030, yeah, to 2040, something like that.
That's right. So it goes up sometime because you keep getting more gas, and you can increase the amount you produce with your gas plants. And as we showed in the other two graphs, NGLs have indeed been a key part of what we've produced since the plateau of conventional oil.
So what is the difference between NGLs and NGPLs?
PLs are produced at formal gas plants, and NGL, the gas comes up from the gas well. Don't forget, it's gas wells, it's not an oil well. It comes up gas, but some of it condenses right at the surface as it comes up. The pressure changes, the temperature changes, it condenses out and is effectively a type of petroleum, natural gas liquids, and that's separated off. Sometimes it's counted in the oil production, sometimes it's not. That just comes naturally at the surface, but a plant, you've got to change the pressure a little bit, reduce the pressure, and then suddenly out comes the plant liquids, and you send them away at that pressure. So
so they're kind of like lighter than regular NGLs.
It's like naphtha, natural gasoline, those kind of molecules.
Yes, absolutely.
Okay.
Dan, yeah. Thank you, Dan. Dan knows more about this than I do, I have to say. Next slide, please.
Okay, sure.
So that was NGPLs. Now we're looking at shale gas. Now, I will warn you, the information on conventional oil and conventional gas, very solid, long linear lines in the Hubbert linearization curves, 20, 30, 40 years of straight lines, pretty convincing. Now we're moving to products, gas, shale gas, and then coal, where you're not looking at long straight lines. John, you happy with this?
Yes, I do.
Good man. So now we're looking at more indicative information that isn't as solid as conventional oil and conventional gas. But if you look at this one, there's a few years straight line that would seem to indicate 16. Who knows where we're going to go with shale gas production? You're not allowed to do it in the UK. You're not allowed to do it in lots of European countries. China's been looking very hard and found some, but it's a tough old road to be a shale gas producer if you're not in America. America's a lovely place to be a shale gas producer. Everybody owns their own. You sit on a farm and you own the minerals underneath you. Nowhere else in the world is that true. You don't own the minerals, sadly. The government owns the minerals.
Roger, somebody who's actually done some horizontal drilling and fracking for shale requires the right kind of geology. For example, I know a lot of people want to do horizontal drilling and fracking in the shale out in California. The problem is it's so faulted and fractured, you can't pressurize the system. So only in certain places can you do horizontal drilling and fracking shale.
What's your own take, Dan, of how far around the world it will go? Who do
I
you
think
think?
there's a great opportunity in Australia, and there's a greater opportunity in Russia. I think that's the two places where you could do horizontal drilling or fracking with shale.
The two big ones.
Yeah.
Okay, very interesting. I mean to go and talk to the UK Geological Survey. I haven't done it. It's on my to-do list to go and talk to them
But
about.
you might be, I don't know, but if it's possible to horizontally drill the frack under the North Sea, that might be possible too. But that's a good question.
Yep. Thank you. Okay, keep going. We're nearly there, Andrew. So that's shale gas. And if that's the HL, and if that is the ultimate URR, the ultimate recoverable resource, 16 gigatons, coming back to tons, then that's what you get. You say the world is, coming back to what Dan is saying, there are other places we're going to look, but the rules are different. Not everywhere is geologically sound. And Jean certainly says on this basis, he sees that probably shale gas is also about at peak, about now. Globally, there'll be plenty more, but it goes down slowly, but it's at peak-ish. Okay. Now we switch from oil and gas to the third last fossil fuel. Only 3 fossil fuels as well as kerogen. This one is brown coal. You've got to be careful. There is a lot, of course, coal. There's thousands of tons, but gigatons, I mean, but you've got all sorts of modern constraints on producing coal, just straightforward polluting the air, then CO2, then costs and so on. So here you have got sort of straight lines, a bit ambiguous, but 130 to 150 gigatons, same Hubbert linearization plot. Data again, ASPO France.
If you don't mind me adding a little bit here, Roger, remember the guys, this brown coal, this is lignite. It's brown, yes. Really has a high water content. 2/3 of this is not carbon. You got to remember, high water content, 2/3 of it is not carbon.
Dan, I didn't know it was 2. Thank you. You educate me. I knew it wasn't as good as dark black coal.
Coals are graded in, again, the carbon content by weight is how they're graded.
Yes. Thank you. Next one, Andrew, please. So that was brown coal. Now we come to a nice HL graph that's ambiguous, hard coal. Okay, we know there's lots of hard coal in narrow seams and very deep and under the sea. The coal in England is the same coal as in the Ruhr in Germany. You just have to go under the sea to get it. But if you look at any of these charts, you can't see it clear. But Jean, in this year's analysis, is more pessimistic's the wrong word, more conservative is the word on his total amount, and he sees 500 billion tons of recoverable hard coal production because of all the constraints we've talked about. Hard to know from, you haven't got a clear Hubbert linearization straight lines, but he's assuming 500 is a reasonable estimate. Gigabillion tons hard coal, and so if you put that together, you then get the next, we're near the end, you get the next chart, which is the 2 coals. You've got the hard coal, that dark line up going off to the 500 gigabillion tons, and you've got the brown coal, which we've just been told is much of its water. I didn't know that, and it's been kind of a uppity downy, but again, that's the amount, assuming 140 tons of recoverable brown coal. Thank you kindly. Next one, please, Andrew. Which gets us back to where we started.
Oh, Roger.
Okay?
Yeah, go ahead. Yeah, I've just had to mute someone that just joined.
Okay. So it gets us back to where they started. This is the same chart you saw at the beginning. We'll put it into context. That is, you've got the hard coal dark, oil green, oil, gas red, shale is no, brown coal is the brown, and then you've got shale and coal bed methane, which we haven't discussed. And many of them go over peak now or just recently. So the estimated dates are brown coal peak 2012, crude oil 2017, as we say, conventional oil 2005, plateau 2008 going down, 2017 oil, conventional gas 2019, so in the past, hard coal about now, and then the others can be smallified a little bit, Andre. It's a bit big.
It's a bit big. Okay.
Yeah, I want to read the blurb underneath.
Oh, you were reading the blurb. Okay.
Yeah, that's right. There we go.
There you go.
Always read the fine print.
Yeah.
So for conventional oil, conventional coal, these dates are pretty damn certain. They reflect intrinsic limits to how much you can produce. You know, if the price goes up spectacularly and we're desperate for the oil and the gas and the coal, then we'll produce some more, but not much with those constraints. Coal is different, but then we know that even China is just beginning to move away from coal. I'm very pleased.
Mm-hmm.
Production costs, CO2 limits, other factors. So this is an extraordinary picture, and really we're in Jean Laherrère's debt for putting it together. It is conservative in places, coal and brown coal, but it is telling the world that if you want to live in a fossil fuel world, and we've had a century of wonderful growth and prosperity on the back of all this. This is Gail Tverberg's area of expertise. We've had a wonderful century of growth and profit and stability and good food supplies and summer holidays and winter holidays skiing, all produced by coal. I go back to nice coal fires in my school and my home and petrol in my dad's car. But we're looking at a changed world. Now, we have got a changed world. We've got small modular reactors with nuclear fission. We've got fusion. We've got lots of solar energy. But it is a changed world, and nobody has yet, and this comes onto your specializations, Andrew, nobody yet has done all the sums correctly to look at how we go away from this wonderful supply of fossil fuels that made us comfortable to a world where we have other supplies. And as everybody knows from other charts you've seen, we're not yet transitioning. We're bringing in the new fuels, but we're not reducing the old ones. Mm-hmm. So it's a big, big question that Andre's chat shows discuss. Next slide, please. 2 further readings. I won't go through them. If you only read one document in this whole area at all, you've got to read the Scientific American End of Cheap Oil. It makes it very clear it's talking about conventional oil. It mentions it, I think, 13 times, if I count it correctly, though you still get people writing critiques who said, oh, no, we haven't had end of conventional oil because they don't understand it's conventional. And so there's Campbell, there's a wonderful, and there's one more, and then we're finished. So another set of, next slide, another set of further reading, which if you've got time, but certainly read Scientific American. Sean, have I done that justice? Is that fair, do you think?
I think it's fair, yes.
Thank you. Merci beaucoup, monsieur. And
Right.
if anybody wants a chart produced, Jean Laherrère is your chart expert.
Mm-hmm. All right. And so do we have any questions from the panel about the presentation? Or anything? I guess we kind of know a lot of it already. Let me check from...
I can...
Go ahead, Ivor.
I was wondering, okay, so we're at the sort of the peak of everything right now, more or less, figured out in gigatons total. Or are we a little past the peak of kind of everything right now? Just curious, kind of add them all together, you know?
No, well, Jean's numbers will show you've got to go to the big data sets to really look, but I don't think we're past the peak. We're about at it, I think is the right thing, Ivor. About at it.
Okay. We're about at the peak of everything, huh?
Yeah.
Okay. Thank you.
Yeah. It looked like only the coal was really a question, and we're past peak both in terms of the liquids and the gas.
Yes. Certainly conventional oil, conventional gas is solid peak. The others are more interpretive and does depend on what we do. And there's no question, if you let's take UK. I think I mentioned this once before, Dan, on your chat shows. If you really needed oil, if oil was necessary, like I know, to stop disease, we would go to the North Sea. We would put in huge caissons. pump all the water out and then go down and drill up all the oil rock, and then we put in acetone and dissolve out the oil.
Yep.
You can get much more. Our recovery factors, they're now 40% world average. There's a lot. And Rystad makes the point. There's a lot of potential extra recovery, but it costs more money, and we're already up at nearly $80 a barrel. It costs more money. Too high an oil cost destroys economies. Mr. Trump isn't happy that gasoline is $4 in America now, not $3 a gallon. So, you can get more, but it costs you, it destroys your economies.
Roger, add on what you're talking there, and how I got drug into this 20 years ago, had to do with converting coal-fired power plants over to gas turbine. And the reason why was because of the quality of the coal. When you're down to the point where you've mined out all the hard coal, the bitumen and the lignite, and you go down the bitumen and the anthracite, what's left is the lignite. You can't run a power plant on the lignite. The cost of diesel exceeds the energy content of the fuel. And when you're talking about oil and gas, so forth, understand 2/3 of those the hydrocarbons are still in the ground, right? We can only get so much out using water, using CO2, using steam, right? But that, like Roger said, the only way to get at it, like he said, is to actually tunnel down 6,000 feet and physically, dig it out and somehow, use paint thinner or something like that, or steam, whatever, to physically dig it out. But the costs of doing that are just astronomical. So that's
exactly right. Yeah.
Yeah. So am I understanding correctly that then we're talking about more like ultra heavy crude, similar to the Canadian tar sands?
It'd be something similar to that, but you'd have to dig through 6,000 feet of rock to get to it.
I see.
Think about the engineering of that.
Yeah. So it would be a low EROI.
Yeah. I mean, think about some of the deepest gold and diamond mines that we have in the world. That's like kind of engineering, and you'd be in a massive amount of quantities you'd have to dig out for the hydrocarbons. Is it really worth that much to dig out the hydrocarbons? Not compared to like diamonds or gold, which are high value products, compared to a product like hydrocarbons. Are we willing to pay that much for it? I mean, that's I'm guessing when it gets to a certain point, you're going to get demand destruction, which was what we're seeing right now. Yeah. One of the reasons why oil isn't higher than what it is right now is a lot of different factors, but part of those factors is demand destruction. People in Asia are just not driving their cars. And that's a good example.
Now, don't forget, Andrew, that's a very, Dan, excellent points. I just very quickly, don't forget your EIA, the American Energy Information Administration. When American oil was going down year after year before the shale oil, the fracking oil, the EIA used to say, well, we'll get our oil from Kerogen. And America is blessed with an awful lot of Kerogen. You've got 1,000 billion thingies of Kerogen. Yeah. But again, you're back to rock, you're back to Dan's point. You've got to get and there have been some projects, and when oil was a bit more expensive, the Kerogen boys came forward and said, we can produce it. You've got to it's all in the rock. You've got to get the rock up, crush it, and then heat it, and then get the oil, and then change it. You've got to pyrolyze the Kerogen to turn it into oil. So yes, it can all be done, but so there's a lot there, but it is expensive and difficult. And so Dan's quite right.
Okay, I have a YouTube question. How do the bottlenecks in the Gulf, Red Sea, and Black Sea affect the charts?
Thank you kindly, Andrew. None at all, not one bit. They're fun, very good questions, and we're facing very interesting times. And we've been asked in some of the papers we've been asked to write, we've been asked to put in some reference to the Strait of Hormuz and stuff, but I fought against it. Strait of Hormuz is a political thing right now, and it could be solved. It probably won't, but it could be solved tomorrow. Oman and Iran are talking. It's nothing to do with resource limits. What we're talking here are fundamental resource limits, how much there was in the ground, how many years we've used it, and how much we can use in the future. Nothing to do with politics.
Roger, there's another kind of question here too, and that is, we live in the age where we've pretty much mapped out of the planet Earth geologically. And the United States Geological Survey and other surveys have drilled and pretty much mapped out the planet as to where certain types of resources are located at. So we're kind of blessed in that regard. And the other side is we're kind of cursed because we actually know what those numbers are, and there really aren't that many blind areas out in the world that we don't.
And a very good point. I know not enough really about how Jean got into all this, but that's certainly how Colin Campbell got into this. He was in South America. He was looking at South Americans' availability. He knew what he drilled. He knew what they hadn't drilled. And then when he's asked to look at the next area, his company told him to look at other areas. He slowly started to realize, and it wasn't immediately, that, oh boy, we had, exactly as you say, we have drilled most places. Our geological knowledge is solid. We know what we're doing. We have drilled most places. There are some good places to go and look, but not many. And the classic story we had was we gave a lecture 25 years ago at Reading University. Along came the really big oil companies, and we said, look, conventional oil is going to go over peak soon. And a senior man from Chevron, I think it was, said, no, this can't be true. We've just found a big new field offshore. He wouldn't even say where it was, but everybody in the room knew it was Namibia, because they're all oil experts. So we've just found this huge field in Namibia. How can we possibly be running out? And as you say, Dan, we know where it is and we know how much there is. And, a big new field in Namibia helps, but it doesn't stop conventional oil going over peak.
I know Gail also has a lot of information about how the price might not go up even with scarcity. I don't know if, Gail, you wanted to speak to that.
Anyway, thanks, Andrew. Much appreciated.
Mm-hmm.
Yeah. Well, the area I look at, let's see.
Yeah.
The area I look at has to do with more how the economy is hooked together in a very strange way. And we expect the prices to go up if there's a shortage. That's why you said the end of cheap oil in 1998, this is the way it was interpreted if we're running short. But it doesn't turn out that that's the way it works out in practice. It's the end of as many finished products as we'd like. And the way our ability to buy those finished products is changed is by young people getting poorer and by wage disparities. And it fits, the system works differently than we would expect. And if we look back, what happens is that there are wars that take place when you start reaching these limits, and you have things like the collapse of the central government of the Soviet Union. So there are things that people don't think of. My analysis looks at this from a different perspective as to what happens when you hit limits to growth, basically. And so, it's not the story that the idea that the price will go up isn't quite right.
Mm-hmm. Thank you, Gail. And I know Arthur Berman has joined us. And you have a presentation for us as well. And Gail will be presenting next time. Okay, Arthur, I don't know if you could unmute and say something.
Yeah, okay. Hi, Andre. Yes, I do have a presentation. Do you want me to run it from here, or you want me to send it to you? What would be best?
Okay, yeah, you could try running it, or if you prefer, you could email it to me, and then I could go through the slides.
Okay. Well, we can try it.
Okay.
So I'm going to need to share my screen. You'll have to talk me through how to do this on this.
So it's the third button at the bottom. So there's the microphone, the video, and then the third one is the share screen.
Okay. So share screen.
And then you can select either entire screen of where you're going to have the presentation.
Settings. Okay. Gosh, allow.
Or you could select the window. Oh. Oh, Arthur accidentally left. Okay, well, hopefully we'll... Dusty, go ahead.
Okay.
You have to unmute first, Dusty.
While he's getting his tech stuff figured out, I figured we could just chat a little bit more about what Gail was talking about.
Mhm.
That is a really interesting way to think about how monetary things can cover over physical reality for a period of time. And thinking of it in a generational / political sense is very interesting, that I'm going to have to think about more, because it does seem like the burden of lower EROI oil is being placed on the shoulders of the younger generations, which aren't politically impactful yet. So that might be part of the play here. It's a lot to think about.
Mm-hmm.
I don't know if anybody has a comment on that.
Yeah, no, that's a great point. And I know, like, I'm running for mayor of Owen Sound, and part of my platform is rural affordable housing and making housing affordable housing legal again. For example, currently you're not allowed to make a unit that would be affordable for young people. And so, but I did the calculations that if you have a yurt and full insulation, and with like composting toilet and rain catchment, it's 56,000. So young people can actually afford that, and it comes with like 2.5 acres of land, and the payment's only 500 or 700 a month. So it is doable. There are ways of having it working.
Do you think that could potentially be, though, a tactic that's used by people in power that are, using monetary system to sort of cover the realities of peak oil, and they're, putting the impact on people under 25 that don't maybe vote as much or aren't as impactful yet? Does that seem like a plausible hypothesis?
Well, I think there's always some of that, just because of people, younger people don't vote as much and older people vote more. And so politicians have to appeal to the people that vote to them. However, right now, the average boomer is already 70 years old, and the life expectancy is less than that. So a lot of the boomers are dying out, and so we're having more millennials. Hey, Art. There, I can't hear you now. You have to unmute.
There we go. I'm unmuted. All right, let's try this again.
Okay. Very good. You want to try sharing again, or you want to email it to me?
I'm gonna try. Yeah.
Okay.
And then we'll go to PowerPoint if it's not letting me select it. Okay. Entire screen. Okay. Then we'll go to.
Okay. Yes.
There we go. Okay.
Yeah,
great.
we're seeing it. Yep.
All right. So let's.
And then you can go into presentation mode.
Yeah, there we go. All right.
Yep.
Are we seeing?
Yep.
Okay, great. So this is just a brief summary of what I think is going on right now with oil systems, and I'm going to explain or try to explain a few of the things that perhaps Gail was alluding to minutes ago. So first slide summarizes basically how 20 million barrels a day of lost oil and refined products and natural gas liquids and a few other things that were coming through the Strait of Hormuz. Instead of losing 20 million barrels, in the end, we only lost about 4 million barrels. And without going through all the details, basically the biggest factors were bypass pipelines that were already built that could avoid having to go through the strait. One pipeline went west to the Red Sea, and the other one kind of cuts around the backside of the United Arab Emirates and comes out on the other side of the strait. So about 6 million barrels is making it through that way. The other big factors were reduced Chinese imports. China somehow reduced its crude oil imports by something like 3.75 million barrels a day. Another big one was inventory withdrawals mostly from strategic petroleum reserves by the U.S. and other mostly OECD countries. And the final was just demand destruction. We don't know exactly how much that is, but I'm just saying 3 million. So you add 6 through pipelines, 3.75 from Chinese import reductions, 3.5 from inventory withdrawals, and 3 from demand destruction, and you end up with 16.25 million barrels a day instead of 20. Now, the point I want to make is this is adaptation. It doesn't resolve the problem. It's hardly a long-term solution, but it is how the system adapted to what looked like, an absolutely, killer kind of devastating loss of oil supply. Now, 4 million barrels a day is a massive loss of oil. Don't get me wrong, but it sure isn't 20. So,
just to interrupt a second, sorry, I shouldn't, but just an excellent chart that. I wish we'd had that in the newspapers and things. A really good chart. Thank you kindly.
Thank you. Sure. Well, and again, it's they're estimates, but given our confidence intervals, plus or minus 1 million barrels or so a day either way. Then the current narrative in the oil business and chats is that we are right now dangerously close to what some people call tank bottoms, that so much oil has been withdrawn from strategic petroleum reserves that we're going to very soon be at the level where we're getting that giant sucking sound and we can't get any more oil out of our storage. And when that happens, horrible things are supposed to happen. So that is the current story, and as with most stories, there's definitely a kernel of truth to it. But back to what Gail said, markets are not exactly freaking out about this, and so there's a lot of ways you could interpret that. Either markets are stupid, I don't think that's the case, or markets are not taking this quite as seriously as certain analysts are. And I'm not going to answer the question necessarily, but the truth may be somewhere in between. What I want to talk about is this method that I've been using for 20 years or so, which is called comparative inventory. And I don't want to get too deeply into the details or bore people with technicalities, except to say that I think this really cuts through a lot of the crap and helps us understand and explain really what's going on. So comparative inventory is a very simple concept, and all you do is you take the 5-year average of how much oil is in storage, and I'm using the U.S. here, and I'll be glad to answer questions, about why I'm using the U.S., but suffice it to say that over 20 years of hearing people's objections, well, the U.S. isn't, the whole story, and for sure it's not, but empirically it works, okay? And again, I'll be glad to, I'm not going to defend the concept, but I will explain why I think it works anyway. But bottom line is, if you take the current level of storage, and here I'm talking about crude oil and select products that I think are important or most important, including, distillate and gasoline and jet fuel and a few others. If you take what, the 5-year average from minus and subtract that from the current level, that gives you what I'm calling comparative inventory. And it's useful because you're doing it for the specific week or month, if you will, that we're in. So it takes all the seasonality out of it. So you're comparing, how is inventory today with the last 5 years on this particular week. So it takes all the seasonality out of it. And basically what it says is that if you're above the 5-year average, then you're in this blue inventory surplus. And if you're below it, you're in this yellow inventory deficit. And then there's a y-axis in the middle, which is the 5-year average. And so if you're on the surplus side of things, on the right, then basically oil markets are short. They're shorting oil. There's no reason to spend any more money than is necessary on oil. In fact, if markets judge that there's an oversupply, a big oversupply, the market will drop the price and discourage producers from drilling wells. If on the other hand, you're on the other side of the y-axis and you're in a deficit, then markets are going to be long on oil, and the price is going to be higher, and the idea there is to motivate producers to drill wells. And so it's a fairly simple concept. And then there's this sloping blue line that I've drawn in the middle, which is what I'm calling an attractor or yield curve. And you can't see any of the data here, and I'll show you in a minute. But, it's kind of a fit through all the points that I've accumulated. It's not a regression, but it is a trend. So that's the concept. The concept is that, markets are bets. A futures market is a bet. And a lot of people think that, well, how is it possible that oil is only $80 or $85 a barrel when, the Strait of Hormuz is blocked and we have Ukrainians bombing refineries in Russia, and the Black Sea is kind of cut off, and the Red Sea is being threatened by the Houthis. And I don't want to get into, I'm not trying to justify markets, but the key word is futures. Okay, so these are bets that are not being made on the basis of today's conditions, but they're contracts that are being bid on in a month, 2 months, 3 months, 4 months, 6 months, 12 months. So it's the aggregate of all of those. And so markets are saying, well, yeah, we know that things are, bad right now, but we're going to discount the present because for whatever reason, maybe markets think things will be different in a few months. So this is what real data looks like. So here is, in fact, I just updated this morning. And so I'm not showing every point, but I'm showing representative points from the past in blue. And the red point that I'm pointing to right down at the bottom, this is February. So this is just at the time that the war between the U.S., Israel, and Iran began. And March moved up here, April, May, June, July 10th, and as of this morning, we're right here. So what's happened is that we've had a big price excursion. And again, throughout this Iran war, I've listened to analysts complain about, what's the deal, guys? I mean, how come oil is only $95 a barrel or $100 a barrel in April or May when we have this world-class crisis going on? And I can't answer that question except to say that that's like a 30% risk premium. So if you take any one of these points, let's just say this April number is like $100, which is pretty close to what it was, and you just draw a perpendicular line down to the attractor, if you believe it, and then come across to the price and you read it, that's like $70. Okay, so $100 is $30 or 30% more than $70. So, from my perspective, that's a pretty good risk premium. It may not be what everybody thinks it should be, but there it is. But the point is that over the 5 or 6 months of this crisis, we've gone on a full excursion, from kind of normal prices to higher, and now we're back kind of to where we started. This is, last week's data point in yellow. So we're, a few dollars, maybe $5 higher than the marginal cost would be predicted by the attractor. So that's why comparative inventory is useful. It kind of cuts through the crap and says, wait a minute, markets aren't crazy. 30% premium is a pretty healthy premium. And then people say, but during the Iran war or the Ukraine war, prices were much higher. They were $120, $130. Well, here's the data on that. So here's the Iran war in red. Here's the Ukraine war in orange. Again, remember, this is the 5-year average. So in February, when the Iran war started, and even in March and April, we were still on the surplus side of comparative inventory. Okay, so that's part of the reason that markets didn't freak out, because it's like having money in your savings account. You're not happy about having a major expense, whether it's a car or home repair or something like that, but you've got the money in the bank. So, okay, you hate to take it out, but it's not like you don't have it. Now, on the other hand, you move over into this territory on the left, and it's like, okay, well, now my savings are really low. And so if I get an unexpected expense, now I start to sweat it. But even so, the point of this chart is that where we are today, this is July, we're still at a relative surplus compared to where the Ukraine war ended. So again, this is a cross plot. So the Ukraine war began over here, got up to 114.84, and then kind of trailed off. But the point is that comparative inventory, has never been in the same deficit territory as it was during the Ukraine war. So that cuts through some of the crap. That's why prices aren't as high. But the risk premiums, the percentage of premium is actually higher. So if we look at kind of a bigger picture, this goes all the way back to 2015. And so here's Ukraine war, here's Iran war, here are the Hamas attacks in 2022. This is these black points are what happened when oil prices collapsed back in 2014, 15, and then kind of recovered the other way. And it all sort of fits together into a coherent story that oil prices are, I'm not going to say that they're predictable. They're certainly not, but there is some kind of order in what otherwise looks like, may look like kind of a chaotic or at least a complex system. Now, sometimes, I guess the point of all this is not that, I'm not arguing that everything reverts to a mean, because this is not a mean, it's an attractor, and an attractor is a term that I borrowed from complexity science. The system is trying to manage its way back to whatever, seemed like sort of a homeostatic, I don't want to say normal, but you know what I mean if I do use the word. Well, so in the cases that I'm showing here, it looks like everything, always kind of came back to that attractor. So I'm just showing an example where that wasn't the case. So, these are the details of the price collapse in 2014-15 in light blue. There was a little bit of time early in that crisis where people got hopeful and thought, okay, it's all clear. It was just it was a mistake. No, that wasn't the case. By 2016, we were way over here in giant surplus territory. And for many, many months, there was, a lot of kind of chaos as to, we overshooting or undershooting. And finally, markets just said, you know what? We've exhausted the possibilities of that attractor and chose another attractor, a lower one. Okay, and what does that mean? Well, that means that the slope of the attractor is lower, which means that it expresses relatively less supply urgency. So any move either towards surplus or deficit has less effect on price than it did when the slope was greater. And again, I don't want to get too bogged down in the details, except to say that the system adjusts and adapts until such a point as you can't. But it doesn't happen overnight. It takes, just like with our lives, it takes us time to say, okay, I'm no longer going to stay in this marriage. That's not my story, but you know what I'm saying. We try to make it work, and we try to make it work, and eventually we just say, okay, we're done. We're going to try something different. Similarly, looking at COVID, this is showing data from 2018 through 20. We were in deficit territory when Trump first took office, and he decided to walk away from the Iran nuclear deal, decided to put full pressure on Iran with sanctions. And so we got into an excursion away from the attractor. Just about the time all that happened, COVID hit, and we undershot the attractor by quite a bit and stayed undershot for months and months and months, but eventually returned. So the point is that oil is a complex adaptive system, like many other things, markets, life, evolution, and it is attracted to certain tendencies until it can no longer maintain them. So people ask me, well, but don't you think that if the Iran war, Hormuz crisis continues, that we will get into a very serious deficit situation? And the answer is, well, let's see. And that's the beauty of comparative inventory, is that you can, somebody says, well, I think oil should be $150 a barrel. And a lot of people say that. And I say, well, let's actually do an experiment and see what would it take to get oil to $150 a barrel. And so what I did was I just said, let's assume that inventories continue falling at about the same rate that they have been since the Iran war started, and let's just keep that going out some distance in the future. And because I can, going back to one of these charts, I can say, well, here's where we are. What price does that give me? I can play that game forward, and I can say, all right, well, if we continue drawing down our inventories at the rate we have, then maybe by November, I can get you to $150 oil. Now, again, this is not a prediction. It's just a way of saying, you think the price is wrong. I'm showing you why markets say they don't think it's wrong. And you're saying, well, I still think it should be $150. And I'm saying, well, it's going to take a while. It's not going to happen overnight. We have to continue building sufficient deficit so that markets say, oh my gosh, I'm out of savings. Now I'm worried. So a lot of people, again, we talk about the Strategic Petroleum Reserve. This is updated as of this morning. And so you can see, things were up here at about 700 million barrels for the United States. And then here we are in June of 2020, and then Ukraine war hit, and Biden administration started drawing things down. We got to a low of 349. Slowly kind of put a little bit back into the SPR. This is March, end of March 2026. Iran war hits, and now we're down to 305. So we are at an historical low. Are we at tank bottom? Well, this is a controversy. I've drawn two lines on here. One is just sort of a legal limit at which Congress apparently can get involved and say, well, we've reached 252. That's a problem. Nobody really knows what the lower limit of operability is, but my best guess is it's down here at about 180 million. Point of this is, first, we're not there yet. Second, we could get there in not too much more time. Third is, how much does it really matter? And again, is then this is the trend. The trend is, yeah, we're still withdrawing. We withdrew almost 3 million barrels last week, but since the Iran war began, it's looking like the trend is getting better. We're drawing less per week for whatever that's worth. People ask, well, so when you do this comparative inventory, what are you using? Are you including the Strategic Petroleum Reserve? And the answer is no, I don't. And there are many good reasons why I don't. And the principle is that markets don't look at strategic reserves as supply. And you can, go back to this, and you can see that through most of history, it pretty much just stays flat, and that's why they don't. But since people ask, this is the same kind of comparative inventory calculation, except it includes Strategic Petroleum Reserve. And what does it say? It says, well, we're about $15 above the marginal price. So markets do pay attention to this. Markets are saying we think there's, about a $5 risk premium using commercial inventories only. We think there's about a $15 premium using Strategic Petroleum Reserve. So markets say, yeah, this does matter to us. We're not freaking out about it, but it does matter. So that's really all I wanted to present today. I'm not trying to make an argument. I'm not trying to defend the way financial markets work. I'm not trying to say they're right or they're wrong. I'm just trying to explain the way I think the mechanics work, and try to give you some sort of context in which to understand that you can't just say, oh my gosh, we're in a war, and so things should be like they were the last time we were in a war. I mean, that's not an illogical assumption. But then you look at the data and say, yeah, but things are different. Conditions are not the same. And then, well, could we get there? Could we get to the same place? And I've shown you, yeah, we absolutely could, and we could get there, relatively soon, but not overnight. We could get there, in 3 months or 4 months. So that's what I've got to say today. That's my presentation.
Thank you, Art. That was really excellent. I enjoyed it.
How do I get out of it?
Oh, how do you stop sharing the screen? So you click the third button again.
There we go. Yeah.
Okay, there we go. Okay, awesome. Okay, now questions from the panel for Art. Anybody? Dusty, go ahead.
Art, have you done some same work you showed there for the USA, showing like China's reserves?
I didn't hear but the last few words of your question.
Oh, sorry. Have you done any of the similar work on China's reserves compared to the USA?
Okay, well, I knew this question would come. No, because nobody knows China's reserves. So you have to have data to be able to do this. And so the reason that I use U.S. reserves is because the U.S. has a very accurate and timely reporting schedule. Every week they provide a number. Now, if you look at OECD, the same countries that support the International Energy Agency, I can get data on that monthly, and it's not nearly as good. There's a lot more uncertainty at estimates, but I do calibrate what I have. We have no idea what China's reserves are. Absolutely none. Well, I wouldn't say absolutely none. We can guesstimate a number, but we have no way of knowing how they change from week to week or month to month. Similarly, we have no idea of Russia's reserves. Basically, we don't know, and so the answer to your question is it's purely empirical, and that is that I've been using this method for 20 years, and it always works. And the reasons that it works, I think, are that the U.S. is both the largest supplier and the largest consumer of oil in the world. U.S. accounts for 45 or 46% of OECD storage, and so the United States, for reasons of data credibility, reporting frequency, and because we are such a central part of not only the oil production and consumption part of the equation, but we remain the kind of the financial center of the world for reasons no more compelling than it's worked for 20 years, and I just led you through an explanation that I think is probably as credible as anyone can show you as to why prices are where they are. It still works. So that's not exactly a proof, but I guess I take what works over theory any day of the week.
Okay, Ivor, and then Dan.
Yeah, I was wondering if this is kind of like I went into a store recently, the West Marine store, and they're going out of business, and they're selling everything at like 50% or something. I was wondering if this is kind of like the world's inventory reduction sale. Is that what's? I mean, this is just speculating. Are we kind of like selling the stuff, getting it out there before the world economy crashes, or what's the deal? Just an idea.
Well, I do think that this Iran war is a world-changing event. I think that we are going through an energy phase shift right now, regardless of what markets may think or not think. I don't believe that this is something that we're going to look back on in 2 years, 3 years, 5 years, and say, "Oh, it's just another bump in the road." No, I don't think that's the case. I mean, energy is the functional metabolism of the global economy, and the fact that energy and oil markets are as adaptive as they've shown themselves to be over the last 5 or 6 months is impressive. That doesn't mean that, as I said in the first or the second slide, adaptability is not the same thing as resolution. So, in the same way that COVID is still with us in many ways, even though we don't want to admit it, or the great financial crisis is still with us in many ways, even though we don't want to admit it. I think this is bigger than either of those personally, but that's an opinion. I can't. I don't want to pound the table about it, but and so my sense is, I don't think the world is coming to an end, but I think the world is fundamentally changing, and one of the ways that it's changing is that the way that the world partitions and allocates energy resources is fundamentally different than it was a couple of years ago. I mean, we're increasingly in two geopolitical camps, and what's happening in the Persian Gulf right now is quite significant, beyond the details of how many tankers are getting through and et cetera, because the entire post World War II global order was based upon a number of things, including the Bretton Woods Agreement and the U.S. being the policeman of maritime free trade in exchange for the privilege of having the U.S. dollar be the world reserve currency. And what this Iran war is showing is that the United States can no longer uphold that part of the grand bargain. And again, I'm not in any way saying that I think that the U.S. dollar will no longer be the world's reserve currency, but this is a blow to U.S. geopolitical power globally in the Persian Gulf. And it was Henry Kissinger many years ago who said, "Control oil. If you control oil, you control nations." Well, the United States no longer controls the main source, the single largest source of oil in the world, and guess who does? Iran. So, and again, I don't want to be taken the wrong way. I don't think Iran has suddenly catapulted to superpower status, but it clearly has a lot more leverage than it did 6 months ago.
Yeah.
Mm.
Thank you.
Dan?
Yeah, I just wanted to add on to what Art was talking about. It mainly has to do with Dusty's question here, and I think Art kind of alluded to when he was talking about the petrodollar, and that is what's going on there in Asia. If you look at the country of Kazakhstan, Kazakhstan was using a Russian pipeline to deliver oil to ports there in the Black Sea. And May 1st, they shut that down. Well, if you look at the satellite surveys that the Chinese built between Kazakhstan and China, the capacity there has to be close to 3 million barrels a day. So there's another source of oil that we don't know. Just looking at the satellite pictures of the pipelines these people physically built between those two countries. And then the other thing you have to remember is that the Russians and the Chinese built the Power Siberia oil pipeline system, and they're still talking about the Power Siberia too, right? So there's all this significant infrastructure between pipelines, oil and gas, also railroad systems. There's a major railroad system between Tehran, Beijing, and Moscow that we don't talk about. So there's all this major infrastructure that we're now basically starting to see what the effects are. So as far as what China's reserves are, or truly what even Russia's reserves are, that you're really going to have a hard time even determining what that is, because of all these infrastructure that these guys have been preparing for the last 20 years. I mean, we're seeing the results of 20 years worth of military preparation by the Iranians, right? And that's what's causing this kerfuffle that we're dealing with. We're finding out that that's not an easy nut to crack. Is what we're finding out.
No, those are good points, and certainly I think Putin discovered this, and we didn't learn the lesson, and that is that it appears that the age of shock and awe conventional military, it just isn't working very well anymore. Not that it necessarily has worked very well since World War II, if you want to look at the record, but Russia should have conquered Ukraine years ago and has not, principally because Ukraine has found ways of using a different kind of warfare.
Yep.
And the United States should have crushed Iran, except that it didn't, because Iran's unconventional or asymmetric warfare was, they're not going to defeat the United States, but they were able to keep the United States from defeating them.
That's a perfect point there, Art. That's a perfect point. Warfare has changed, and the United States didn't learn their lesson. I know in defense groups I work in, we've been talking about the drone warfare for years, and for whatever reason, and I was part of the Law's laser program for air defense systems, but the government never adopted it, and now we're paying the price. Warfare changed. The United States government didn't learn their lesson. That's the truth. That's the unfortunate truth. Excellent point, sir.
So I think I saw Gail. Did you put your hand up, or was that?
Yeah,
Okay.
I was going to say, I think what Art is saying and what Gene is saying too is that we're going through an energy phase shift, and what the markets are pricing in is current inventories, which doesn't have anything to do with the phase shift. And when we're looking at phase shifts, strange things happen. What my study shows is that you get collapses of central governments. Now, let's just suppose that the central government of Japan collapses, or the central government of some other country that's running into difficulty collapses. I have one slide that shows how the demand of the Soviet Union countries collapsed over a period of years after the central government collapsed. How their consumption went down. It even went down of nuclear and of hydroelectric as the economy collapsed. So while we think that it's going to affect the prices, what happens is that demand goes down in strange ways very quickly.
Well, demand
I can't.
is, I mean, that is the way that the system can most easily clear itself, isn't it? But I guess the comment I would add is that um, supply and demand are are perhaps the two most important factors, but they are not the only factors. And I deal with this, to change the subject just for clarity. I deal with this in climate change all the time. That you talk to 90% of people, even climate scientists, and they're pounding the table all the time about carbon dioxide. And don't get me wrong. I mean, I don't think there's any question that carbon dioxide is the primary forcing factor in climate today. But to say that it's the only factor, or even necessarily the most important all the time, is incorrect. I mean, you have to look at, it's not just forcing, but it's feedbacks. You have to look at methane. You have to look at water vapor. You have to look at planetary motions of liquidy, and all these kinds of things. And I'm not I'm not saying that in this case CO2 isn't important or even primary, but by itself it's not, it doesn't explain the whole story. And supply and demand is the same; those are primary, but they are not the whole story. And you will not get a satisfactory answer if that's all you're looking for.
Okay. I just wanted to quickly share, because I actually validated Art's what was it called, comparative inventory, and tracking it using some graphs over here. And so what I found was that it tracks the USO 28% and Brent 13 and 14%. And so I just wanted to quickly show this. And so here is the inventory tightness. Like, this is the regular one, but it can be a bit confusing because it's when the inventory tightness is low that the prices go high. And so I got the inverted one to make it easier to see. And you see it tracks the USO pretty well. And in terms of explaining the price, what actually seems to work very well is the global M2, and that has a 53% correlation. And so with the z-score, so you can see here, this is kind of if you do it at the same time, but it basically leads by 4 to 5 months. And anyhow, so then you can see the relationship there. Okay, yeah, I just wanted to quickly share that. And I don't know if Art, you had any comments on it.
Yeah, the only comment I would have there, Andre, is to be careful about circular causality, because I mean M2 money basically. I mean, money is a claim on energy, and so if you want to think about it, money is a derivative of energy. And so the fact that money correlates to energy is, that should be, it has to.
Yeah.
But then to leap from that to M2 is causing oil prices, I would say, I mean that's a leap that I wouldn't take. That's a correlation that has no causality behind it.
So I'll just show this a little bit again to explain a little more. So there's a 5-month lead. So if the money supply goes up, then 4 to 5 months later, the price of oil goes up. And it explains about, what was it called? 53% of the price. So there's still 47% of the price that is due to other factors. Okay. I hope that makes sense why there's a causality. And it has to do with, like you're saying, it's because if there's more money supply, then people use more money to buy oil, or they can produce more, or whatever. And it's just that the relationship is very clear over the entire time that we have these indicators.
Yeah, I'd say the correlation is clear
Mhm.
because you're measuring. I mean, like I said, money is a second or third order derivative of energy. Energy is the economy, and money is a variable in the economy. So the correlation should be strong, but the causality, I think, is probably devious.
Yeah, it's just about the price. Okay, so let's go to Dusty. I think Dusty was next. Dusty, I think you're muted. Dusty, you have to unmute. Okay. Nope, you're still muted. Okay, I'm gonna go over to Ivor.
I just wanted to mention something that I found very interesting in the last couple of months. Apparently, somebody heard that there was a shortage of diesel and stuff, and so the refineries decided to pump up not diesel but the production of jet fuel, and so jet fuel went way up, and we produced a lot of it, and then of course that caused not very long ago, like a week ago or something, was the biggest day of commercial aviation ever. So I was thinking, this is the way things work. It's almost like the buffet line or something. Everybody hears that the steak is going to run out. So when they get to the part of the buffet line where the steak is, they pile on like five of them or something. So I was thinking our whole culture has, we want to go right to the flying around part instead of producing diesel that could be used for something. Anyway, I just thought it was an interesting thing.
Go ahead, Art.
Yeah, I'd be real careful about that kind of argument, Ivor. Diesel is expensive because of logistics. And so if you go to a place like Singapore or Manila, um, the cash price of diesel is $150 a barrel. That's not because there's a global shortage of diesel. It's because uh, the supply lines to places in the world that don't have their own indigenous supply have been broken by the Hormuz crisis. And the refinery issue is a whole nother level of complexity. Basically, uh, ever since probably 2000, well, since the collapse in oil prices in 2014, but certainly since COVID, an awful lot of global refineries have gone offline because they were old, they were inefficient, they were not profitable, and so we're limping along on a reduced level of global refinery, and there has been an understandable hesitation to make those multi-billion dollar, 30, 40-year investments because of concerns about, peak oil demand and energy transition, et cetera, et cetera. So, and then you add on to that Ukrainian oil, drone attacks on Russian refineries. I mean, Russia's actually, it's a second largest oil producer in the world, and it's importing gasoline from India because its refineries aren't working. So, the problem you point out is real, and I'm not diminishing it. But I'd be a little careful about, interpreting, any kind of price gouging. And the jet fuel thing, jet fuel and diesel are geochemically not that different. I mean, there's an overlap, and so a refinery can shift what it calls its slate. It can increase jet fuel by 10 or 15% at the expense of diesel, and it can go the other way towards gasoline also, just by putting more of it through various catalytic crackers and other kinds of processes. But the bottom line on jet fuel is that demand for jet has not been affected very much because people value travel experience. I would have thought, and many people would have thought, that jet fuel consumption would have cratered because it's largely discretionary. But apparently, people are willing to pay a premium to continue to travel and have those experiences. So, uh, we don't really understand how all of that works. I guess is what I'm trying to say.
Okay. Roger, would you? Go ahead.
Yeah, thank you, Andrew. Just to say, excellent talk. I'm some very, very good points. I'm very pleased. I've got to leave, unfortunately, but I'm very pleased to have stood in for Jean, and to have had this opportunity to give our slides and this talk. And Andrew, very much appreciated. Really good conversations and good information. So unfortunately, I must pull out now. But thank you very much indeed.
Okay, thank you, Roger. Okay, Dan.
Yeah, just everybody seems to praise the fact that the Chinese aren't importing 4 or 5 million barrels a day, but they also seem to forget, well, how they did that is they stopped exporting diesel, gasoline, and jet fuel, right? And so there's a huge producer exporter of gasoline, diesel, and jet fuel that's not in the market. They're not importing it, and therefore they're not exporting it. And the thing going on there in Russia with the refinery outages, between 30 and 40% of the refineries being out right now, the Russians are buying jet fuel from the Japanese, which is a heck of a place considering the Japanese are paying some pretty healthy prices for crude oil in that part of the world. So even though we're not seeing the high prices here in Asia, when I talk to people in Japan and Korea, they're paying $110, $120 for a barrel of crude that they're turning it into jet fuel and selling it to the Russians for close to $200 a barrel, right? And we're just not seeing it in our part of the world.
Okay, Dusty, and then I have some YouTube questions.
Okay. It seems like the United States has been very good at hiding reality and kind of insulating us from it. Like you mentioned there, Dan, like different parts of the world really dealing with reality kind of brutally. My question is, maybe to Art or Dan or anybody, is this stuff is too big to fail, right? But it seems like governments have a certain limited ability to cover that. So if demand is lower, if the prices are lower, and the supply is all low at the same time, can governments step in and keep refineries from going bankrupt or closing down? Like, what's the process there?
Art, go ahead.
Well, refineries are not going bankrupt. Refineries are making money hand over fist. What's called the crack spread, which is the margin that a refinery makes compared to what it pays for crude oil, is essentially equal to the price of crude oil. The 3-2-1 crack spreads are running $60 to $70 a barrel at the moment. So the problem that I tried to explain.
Art, you need to explain that 3-2-1 to them because they don't understand it.
Okay, so if you take the three major components of the refinery, which is crude oil, gasoline, and diesel, and you do a ratio of those, weighting them accordingly. I won't get into the details. You end up with, and you look at the relative pricing, what it costs you for the crude oil and what you're getting paid for the refined products. You come up with this thing called the crack spread, which is, if I pay, let's say, $50 a barrel for crude oil, and the money I'm making on the refined products, the gasoline and the diesel, end up being $100, then my spread is $50. Okay, so that's essentially what that is. So, but the point is that refining is a hugely profitable business at the moment. The problem I was describing, and part of the reason that they're so profitable, is because there aren't enough of them. Right? So I just want to keep And to your other point, Dusty, about the United States hiding information from people. I mean, I think the business of all governments is to hide information from people because the truth doesn't get you reelected. And there's Jimmy Carter was the perfect example of a guy who was too honest. And so many of the people here are as old or almost as old as I am. Can remember when Jimmy Carter got on television, whenever that was, back in 1979 or 1980 or whatever, and he was wearing a cardigan sweater and he was in the White House. And he was saying, we got to conserve energy, you guys. I mean, we're kind of running out of it. We're going to have to start looking at renewables and nuclear, and I mean, that was the end of Jimmy Carter's presidency because people don't want to hear that. They don't want to hear that abundance isn't the story. And every U.S. president since then learned the Jimmy Carter lesson. And they will tell you every time, despite what the reality is, that there's no problem. Because that's what gets them elected. But that's not a unique situation to the United States. I mean, that's the way governments always have been. And I will give China credit for having done better planning in many cases than the United States. But I'll also say that, if you don't have a Congress and you don't have an electorate to disagree with you, there's a lot of things you can get done. I mean, for the United States to compete with China on, things like, electric cars, for instance. I mean, they're not profitable, but China said, hey, we don't care. We're going to be the #1 producer of not only electric cars, but all the components for a variety of reasons, many of them strategic, and we're going to fund this whole thing from now until kingdom come. Okay, you can't do that in the United States because you'll get voted out of office, but you can't get voted out of office in China because it's an autocracy. So, so true and fair enough, China has done a better job, or Iran with their drones. But again, it's not like you have to, get the parliament of Iran to approve a budget for billions of dollars worth of drones and ballistic missiles. You just build them, right?
Mm-hmm. So there's several YouTube questions. One from Robin Schaffler. U.S. middle distillates rely on Canadian and to a lesser extent Venezuelan, right? With infrastructure destruction in the Middle East and Russia, could CI for the rest of the world diverge from U.S.?
Well, again, I'll take the question without putting my hand up. I've already explained that that CI, the way I do it, is based on the United States.
Oh, right.
And calibrated to OECD. I mean, nobody knows what global CI is. But the simple answer to your question is, first of all, I mean, Canada is the leading exporter of crude oil to the United States. I mean, 4 million barrels a day, that's 2/3 of what the U.S. imports comes from Canada. So, I mean, the fact that Canadian crude is crucial to U.S. refineries is very well known and unavoidable. Venezuela, is coming back from a big deficit after years of being run by a government that the United States didn't like. But so I mean, but the simple answer is this doesn't affect global comparative inventory because comparative inventory isn't based on
Okay, thank you. Dan, do you want to add something to that?
Yeah, talking about what we get out of Canada. If you look at the United States and draw a line between Indiana going all the way down to Texas, all the states in between, you'll find out we have some of the lowest gasoline prices in the United States. The average in the United States is over $4. But here where I'm at, it's only about $3.36, and that's because we're getting about that 4 million barrels a day. Those pipelines hit for example, the White Refinery here in Indiana. That's why we have such cheap fuel prices. As far as Venezuela is concerned, that's that really heavy crude. We only have 3 refineries with coker units can actually process that Venezuelan crude. So even if it's going to take a long time, a lot of investment to ramp up production out of Venezuela. But the other side is we'd have to go back and reinvest in refineries here in the United States, so they have the ability to process that Venezuelan crude. So that's not the Venezuelan thing's not going to be a simple thing. Right now, they're producing about 1.1 million barrels a day. That's traveling from Venezuela to the United States. But like I said, Chevron already has contracts with those 3 refineries to process that because they've got coker units. So maybe in 15 years, we can get 3 or 4 million barrels out of Venezuela, but it's going to take some time to do it. It's not a simple thing. Mm-hmm. Canada's awesome crude, by the way.
Thanks.
Andrew, you got awesome crude. Awesome.
Thank you. So there's another YouTube question. And they're wondering if people on the panel are familiar with Norwegian Lars Larsen, the end of global net oil exports. Anyone heard of it? Or
that might be a Simon question.
That would be a Simon question. Okay, yeah. All right. I'll hopefully we'll have him on next time. And okay, and then there was someone that remarked that Art had earlier said that peak oil was a failed paradigm, and they were wondering what he thinks now.
Well, I still think it is I haven't changed my opinion about that at all. I'm on the chat because I think it's a topic worth studying. I was on the board of directors of the Society for the Study of Peak Oil because I think it's worth studying. But I think I don't think it is. It's a perfectly good idea, okay? And we will run out of oil eventually. And so I'm not making an argument that it's a bad idea. I just think that peak oil blew its wad. I mean, it made all this noise about how we were going to be out of oil in 2006 or 2007 or 2008, and then people got tired of hearing. It's like President Trump or always on the verge of a peace deal or blowing Iran out of existence, and you say it enough and it doesn't happen and nobody believes it anymore. So my issue with peak oil is not that that the world doesn't eventually run out of oil or run out of affordable oil. And Roger's gone, but his point is very well taken. That if peak oil would have stuck to what Colin Campbell and John Laherrère wrote in whenever that was, 1998, we would have been fine. Which is we're out of affordable oil or cheap oil. Instead, we got all spun off on trying to predict when the peak was, and we just lost credibility. And so that's my answer to that question.
Thank you. Dusty, you have a question?
Yep, and I forgot.
Okay. Oh, okay. All right.
I'll throw it on that, Andrew.
Go ahead.
What Art said, and that goes back to what we've been talking about, and that is, the cheap stuff's gone. And as long as there's 2/3 of those hydrocarbons left in the ground, right, there's always going to be a quest to bring that oil online. Maybe technology will get better to improve it, pull more out of the ground. But it's more a question of cost. What will it cost to actually bring it forth? What does it get to the point to where it's impractical for you to drive your car? When does it get to the point to where you'll say maybe the electric vehicle is a better option than you driving your car? That's really the question. What's that affordability level?
Mm-hmm. That reminds me of what Gail was talking about. But here, Dusty, did you remember your question?
Yes, I did. So I was curious if anyone had seen the recent, it's on this topic of peak or not, that Sabine Hassenfelder. She's a science YouTuber, and she recently had a video about a new drill site that Russia's doing to try to prove the biogenic oil theory. And I'm just curious if anybody had any thoughts on that.
I had some thoughts on it, Dusty, and I've answered it before last year. We talked about the geothermal stuff, and I showed people what was inside of the planet, and it's molten rock shooting up out of the ground in various places around the planet. But the other side of it is I'm sitting on a couple depleted oil and gas fields. There's a place called Shaleville, Indiana, We have a couple gas wells still there, still producing. They stopped it. These were wells that were drilled back in the 1890s, and they stopped producing oil back in the 1950s. Probably here in the next 3 years, we'll be plugging the last of those gas wells there in Shaleville. The other one is Evansville. We're down to basically gas wells down there. So whenever you run out of oil, the last thing that comes out of the wellhead is natural gas. And eventually that natural gas runs out. And I can tell you that right now, like I said, these are oil fields that were drilled back by Standard Oil back in the 1890s. Maybe the oil regenerates, right? But it's not at a measurable scale that we can measure. We haven't, none of those fields regenerate. Maybe it does, maybe over a longer period of time, but not within human measurable levels. I'll put it that way. And Art, you're a better expert. This is really your area.
Okay, Art, go ahead.
Yeah, abiogenic oil is nonsense. I mean, we've been down this path for, when I was a graduate student back in the, when I was riding dinosaurs to school and things like that. I mean, we used to have these conversations, in seminars, and there's no question that there is, some volume of hydrocarbons that are generated in the mantle of the earth, but by virtue of the temperature, I mean, it's going to be methane. Mm-hmm. Only very stable forms of methane can survive the temperatures, even in the upper mantle and the lower crust. I mean, we've drilled the Zildjian ring in Sweden. I mean, we've done this before, and the whole abiogenic theory is based on a mass balance problem that that somehow somebody did a calculation and said, well, we can't account for all the oil that we've discovered based on the amount of oil that we believe has been generated from shale. And so the argument is based on on a data problem, not any kind of fact. So I would place a very low probability of success. I mean, be thrilled if it worked, but I have to say, based on an awful lot of experience, that I think the probability of commercial volumes of anything is close to zero. And I'm with Dan on that if it is anything, it's going to be very dry gas, very dry methane. I think an awful lot of these, these ideas, these technological, Deus ex machina kind of things, they're just technological BS is what they are. I mean, they're bedtime stories that we tell ourselves, and you can, I mean, it doesn't matter if it's oil or renewable energy. I mean, you can pick up the newspaper any day of the week and find some harebrained idea. I saw an article about how some guy figured out how to screw light bulbs into the dirt in his backyard and actually get a current. Well, good for you, buddy. But, the question, and I think Dan alluded to this, it's not whether or not you can do it. It's first, what does it cost you to do it? And second, can you scale it? Can you scale it to make any difference whatsoever in the energy needs of 8.2 billion people? Because if you can't, maybe it helps a little bit around the margin, but I think he mentioned geothermal, and I've done a lot of work on enhanced geothermal. And I got to tell you, I mean, the economics of enhanced geothermal just suck. They're just terrible. I'm not saying that there isn't energy there. There is, clearly. But the economics don't work. Now, can somebody figure out a way to make those economics work in the future? Maybe. But, do you really want to bet on that? And that's sort of what it all comes down to. That at some point you have to figure out, well, a lot of things are possible, but what is feasible? And if it's feasible, can you scale it enough to make a difference? And if you can, what are the other negative effects, like on the ecology and on the environment? And so it's a thorny issue, and the public just wants to believe that anything's possible. They didn't want to hear Jimmy Carter, and they still don't.
Dan?
Yeah, I was going to respond on the geothermal, and I understand it's what Art's saying, and I've had these discussions with Charlie, and I think a lot of it had to do with just data sets, and when people were looking at this basically 20 and 30 years ago. I think, for example, the company Neighbors has made strides in improving the basically the cost and what it takes to drill, and especially when it comes time the amount of time it takes to drill 11-kilometer wells. So I think, but the point is what I've tried to explain to people is there a lot of the choices when you talk about green energy is, do you do the nuclear power, or do you invest more money in the geothermal stuff? And the drilling technologies really needs to come to the fore, and that's really going to be one of those questions: which one are we willing to do? And it goes down to what is it going to cost?
Yeah, I did the economics not on 30 years ago geothermal, but on enhanced geothermal as it exists today.
Yeah,
and acknowledging the best of the best in terms, but it's not just the drilling technology, it's the fracking. I mean, you have to frack those damn wells. You got to pump volumes down into the earth at 15,000 feet to heat up, and you got to bring it to the surface, and you got to turn a turbine on site basically, because you can't transport the. It's to me it's just to me it's not a question of do you do geothermal or do you do nuclear. That's not the question, because both of them are profoundly non-commercial. The question is, if you did all of the above, if money weren't an issue, if the U.S. government just said, you know what, we're gonna underwrite every cockamamie idea, including screwing light bulbs into the dirt in the garden, and you get it all done, and now electricity is 100% accounted for with whatever technology you got, and now you have 80% of the rest of it to worry about, which you haven't solved. So my point is that all these kind of pie in the sky ideas about nuclear and geothermal and renewables, they only account for 20% of the energy we use, and that's the reason that the energy transition is a big bomb, because we're not decreasing our use of fossil fuels, which is the whole reason that we're using renewables theoretically, is because we want to reduce carbon emissions. Well, we've had spectacular success in increasing EVs and solar panels and wind turbines and all of that, but guess what? It hasn't made any difference in emissions or temperature, because we're using more and more oil and gas and coal and so eventually I think you have to say, wait a minute, guys, what are we doing here? I mean, why do we keep focusing on can we somehow figure out a way to keep this party going, when the right answer is, maybe it's time that we all go home and get some sleep.
I agree with you, Art. It basically means we need to rethink the mix that we're using right now. That's very true.
We need to rethink the volume that we're using right now. We need to rethink our relationship to energy, and this thing that's happening in Iran is going to force it on. We're not going to have a choice at some point in the near future, because the flows are down. I would be absolutely bewildered and startled and pleasantly surprised in some ways if Hormuz ever gets back to 50% of pre-war flows. The Red Sea never has, and that's not because we can't get the oil. We can't get the oil through. It's because shippers are unwilling to take the risk. Insurance companies are unwilling to sell the insurance, and the people that have to go onto those tankers are unwilling to do the work. I mean, if you worked on an oil tanker in the Persian Gulf and you somehow managed to get out, and a lot of them still haven't, are you going to sign up to go back in? I wouldn't. So, these are just kind of real world questions that you have to ask yourself. I have to ask myself.
Okay. Gail, I was thinking there have been a lot of comments on transition, and I was wondering if you had something for us.
On transition, I'm not sure I really have a comment on transition. I think that we are headed into a major recession slash depression, I think we're headed into financial crashes. You know, some people are into looking at transitions. You know, one of them, of course, is the renewables, which I agree 100%. It's just unreasonable. But you know, back to the farm kind of things is not an area I have particularly investigated, for example. You know, I think we're going to be running into some fairly huge financial changes that are worse than 2008, for example. So I think I can talk about some of that next time, based on what we've seen before.
Thank you. Okay, Dusty, you had a question?
Yeah, so this following might not be of very much hope, but maybe. And, you know, we talk a lot about all these different things, and my big concern is trying to get younger people, you know, under 40, to talk about this like we do here on this podcast. And recently, Art, you got a shout out on a podcast that's pretty big that a lot of young people watch, and it's a different genre than maybe a lot of people here are used to, but you got called out there on Tucker Carlson's podcast. So I don't know if you heard that yet, but you did. So that's a little glimmer of hope that maybe as we get closer to the precipice of any kind of crisis, maybe the people that are younger that will really be affected by things will start to talk about this topic more.
Could you clarify who got called out?
Art did.
Art, yeah, that's what I thought.
Yeah.
Art, did you have a comment on that?
Yeah, I've never been on Tucker Carlson's podcast, and I'm not sure that I would want to be in the same room with the fellow, honestly. But that's, you know, that's a personal, that's an integrity issue. I don't think very much of the guy's integrity. But apparently what happened was one of his guests is a friend and a colleague of mine. He's a former Royal Navy Commodore, and somehow or other he got on Tucker Carlson's podcast, and in the course of the conversation, he was asked a question, and he turned it back around, and he said, well, you know, the guy that really ought to be answering this is Art Berman. So I think that's what he told me the origin.
Yes, it was a very good episode. I recommend it, actually.
He's excellent, isn't he?
It was great. It was really good. Yep. Yeah. It's definitely up the alley, the conversations of the stuff we talk about here. And I wouldn't call it controversial. You know, even if you don't like Tucker, it was a very good conversation for people here.
Don't get me wrong. I mean, Tucker is a smart guy. He's a very smart guy. And, you know, he's got some instincts. You know, he chases some things that I have to admit, you know, he's on the right track. As I said, my issue with him is more about integrity than it is intelligence. Fair.
Yep.
All right. Okay, I have another YouTube question. Art says we're not going to have a choice but to lower energy use. Is that true of the U.S., which is less dependent on the Middle East?
Yes. And the idea that the U.S. is somehow, the U.S. is 10% dependent on the Middle East. All right. So to say that, okay, so we are less dependent, that's a fair thing to say. But I mean, if I'm deprived of 10% of my oxygen, I'm probably not feeling too well. So, you know, I think we have to keep these things in their context and perspective. And so if you want to talk about the things that, you know, that the government tells us that have a grain of truth but aren't fully true, the United States has never been and never will be energy independent. Not happening. We import 6 million barrels of crude oil a day, as I've said before, and Dan agrees. 4 million barrels of that is from Canada. But how can any country that imports 6 million barrels of crude oil a day have the gall to say that it's energy independent? That's just absolute. I mean, you know, call it what it is. It's a fraud. It's completely untrue. I mean, 6 million barrels a day is more oil than Europe consumes. So, so you got a bean counter somewhere who's adding up, all of the net imports of everything and all the net exports of everything, including coal, including LNG, including electricity and biomass. And somebody, the accountant says, oh my God, the United States is only very slightly a net energy importer, or this month we actually were a net exporter of 59 cents worth of energy or something like that. I mean, this is just stupid, all right? And so, but I think the question is a fair question, and the question is, if we're talking about how bad off you are, I would much rather be suffering through the Iran war in the United States than I would be in Japan, that has no natural resources whatsoever. That's not an argument for things are going to be fine in the United States. It's that they will be less bad. But here's the flip side of that argument. Gail can speak to this. The United States trades with the world, and most of the world is indebted to the United States. And so if the rest of the world is in worse shape than the United States, that means that the rest of the world not only can't buy products from the United States, but can't pay its debts. So now tell me again, is the United States better off or not as bad off? I'd say you could argue that because of the nature of the United States relationship with the rest of the world in terms of trade and finance, the U.S. could end up being worse off than countries that don't have a lot of oil because of all the other knock-on effects.
Thank you, Art. So Ivor had the next question.
Yeah, I was wondering if the recently they said that we're bailing out Japan, buying a bunch of their yen with euros to keep them from selling the T-bills that they have accumulated. They're like the country that has the most of T-bills. I was wondering if that has to do with Japan maybe having to pay more for their, for their oil.
Yes.
They don't have any. Yeah. And
The answer is yes.
Okay,
Yeah.
Go ahead, Dan.
Yeah, the answer to your question is yes. That's exactly what it has to end up. But the thing is, when you're talking about currencies, you're beating a dead horse. And one of the problems we have here is the United States government thinks they control the dollar, and they don't. The banks actually control the dollar internationally. But I wanted to go back to what Art was talking about in the United States. One of the things I have to fight, there's this impression, and it's not necessarily in the world, but especially in the United States, the Americans think that we're sitting on infinite amounts of energy, and therefore that leads to a lot of bad behaviors on their part. For example, one of the things I have a report from the North American Energy Reliability Council that says that in the summer of 2028, the AI data centers, the LNG export terminals, and the power grids are going to collide. And either we're going to have rolling blackouts, or we're going to have to start canceling contracts. And more likely, and that's just contracts already signed for building AI data centers. New York has a moratorium in building AI data centers. And right now, as of this week, the governor of the state of Texas has a moratorium on building AI data centers. And the reason why is they have enough requests in to build for 400 gigabytes worth of demand for AI data centers, where you've got a state that only has 96 gigawatts worth of generating capacity. So what's going to happen between now and, like I said, 2028, Americans are going to wake up to a shocker, and that is we're not sitting on infinite amounts of energy of any type. That the energy is a finite thing, and it's going to become more and more difficult as we go. But you're trying to change that perception is really hard. So we're going to have to do it by shock, unfortunately.
Mm-hmm. Okay, so I guess we'll try to round up now. People were very happy to see us all here. Did anyone have any closing remarks they would like to make?
Thank you, Art, for coming on the show, sir. Thank you, sir.
Okay, yeah, thank you.
Thanks for having me.
Thanks for coming, Art. Appreciate it.
Thank you, Gail, for showing up. Thank you. You're a legend in what you do.
Thank
But
you.
a lot of
Larry.
your,
And
a
I'm
lot of
looking
your-
forward to seeing you on September 3rd, is it?
The first Thursday of September.
Right. Okay.
So I'll just double check here. September 3rd. Yep.
Right.
Same time, and everyone is welcome. Art, you too, if you want, if you can make it. It's kind of an open meeting. All right, and so yeah, and the YouTubers are all very happy, and thank you all as well. And so, as I found you, leave you in the infinite love and infinite peace of the infinite Creator. Go forth, therefore, rejoicing in the infinite power, infinite peace, my friends.
See you later, everybody.
See you later. Okay.
Thanks.
All right, we ended the live stream. Okay.
Thank you. That was